Alright, so we have initialized our algorithm, and F0, our first prediction, is a leaf, and the value is 398, and that's for all the samples. So the first prediction, 398. So let's come back to our golfer analogy here. So here we have the top view. We look from the top down. Here we have a side view. So the first swing brings us here. This is your F0 equals 398. And it's a vector. And it's got, you know, the power of the swing, and it's got a direction. Same here. This is F0. Okay, this is our first value, and you know, our cost function with respect to y is gonna be something like this. It's a quadratic cost function, and here we have our first point. That's our first point. And now let's define a few items. So what we're gonna do now is we're gonna start the second point of the algorithm. We're gonna fit M trees to the residuals. So we're gonna predict the residuals based on the input data. So we're gonna predict these residuals. And so what is a residual? So first of all, we're gonna set M to 1, because here we're gonna have iterations. We're gonna have M iterations. M can be anywhere from, I would say, from 25 to 1,000. So M is our hyperparameter, and it's something as a data scientist that we will have to decide. Practically, the way we will find M is we will do a grid search. We will find that by doing a grid search, which we will see in the coding exercise. So two definitions we want to have here. Definitions. One is residual, and basically the residual Ri1 equals y minus y predict. That's the residual. So y predicting in this case is F0 vector. The I, this is a sample index, and the 1 here refers to the fact that it's our first tree, and of course here we have the I's. Okay, so that's the residual, and then so the residual, we're basically looking to fit this distance here. So here we have. So let us go here. So basically here, when we are here, we're gonna, you know, take our second swing, and that swing is gonna point to y, but it's not gonna directly point to it. We'll make still some error around y. So what we want to do is we want to limit the influence of this residual, and we're going to do that by applying a learning rate alpha. And we will see that, you know, when we gradually move towards I, we'll get very good results. So residual, our second definition is learning rate. The learning rate alpha, and alpha will be a number between 0 and 1. Yeah? So we're going to multiply alpha times the residual. Okay? So basically what it means is we're not going to go immediately here. We're going to take a small step like this one here, alpha R1. And the same thing here. No? It's going to be alpha R1. Okay? So basically what we're going to have is we're going to have to add alpha R1 to F0, and this will be our F1 of X. Yeah? So basically what we're going to do here, yeah, this R1 here we're going to replace with a 3 in order to calculate F1. Yeah? We're going to fit a 3 to the residual. Okay, so where we end up here, that is F1. No, it's again a vector. The same here. Now this point here is y minus F0 squared, and this is y minus F1 squared. Yeah, so let's calculate the residual here. Yeah, it's basically 60 minus 398, right? First point, this is 60, this is 398, that's minus 338. Then 180 minus 398 is minus 218. 250 minus 398 is minus 148. 300 minus 398 is minus 98. These are all minus, and the last ones are pluses. That's 302 and that is 502. Okay, so we have our initial guess and we have a residual, and now we're going to fit a 3 to that residual using the size here, the size data. So we're going to use our data. Okay, so what we're going to do now is we're going to make our first tree, and I suggest that we split here. Here you have everything minus, here you have everything plus. So our first tree will be that the size is equal or less 200. That will be our first tree. Yeah? And what we have here is these 4 points. So minus 338, minus 218, minus 148, minus 98. And here we have 302 and 502. Okay? So now define, now we need to know what the output is of this tree. Yeah? So we need to have a y-predict in such a way that our error is minimal. Yeah? So this we're going to call R11, and this we're going to call R21. Right? The one here refers to the tree number, it's the first tree, and the first one is the leaf index. Yeah, so that's index 1, that's index 2. Okay? So in order to determine the output, and the output is y-predict 1, 1. First one stands for the leaf, and the second one is the tree number, m is 1 equals, and we take the minimum again. So we minimize y-predict so that the sum of half And now we do y minus, and then f0 of x minus y predict square. Yeah. So here again you sum over I. So this is I, and this is also I. Yeah. So that is what we want to minimize. And so let's take the derivative of yp11 with respect to yp. Yeah. And that, what do we get then? Well, we still have the sum over I. Yeah. And we have half. Then the 2 comes to the front. Sorry, the 2 needs to be here. 2 comes to the front. And then we have y minus f0 of x plus yp. And then times minus 1, because we still need to take the derivative of this piece because of the chain rule. And the minus is before the yp, so when I take the derivative, it's minus 1. Okay? This is your derivative. And of course, these two cancel out. Yeah? So we look at the first term. Yeah? Let's have the first term. Term 1. There's 6 terms. This is sum over I. Yeah? Equals. We have y1 is 60. Yeah? Minus. And then f0 is 398 plus y predict. Okay, and then times minus 1. And that's the first term. The second term is 180 minus 398 plus y predict times minus 1. Yeah. And basically we do that till number 4, and what you see is you're gonna add all these up. Yeah. So 60 minus 398, that's this one, right? So that's gonna be minus, so you're gonna add them all up, minus. So the first 4 here is 802. Yeah. So here we have minus 802, and then I have minus yp, and this 4 times is minus 4 yp. Yeah, and this we're gonna set to 0. Yeah, and so yp equals minus 200.5. Okay. So here yp11 equals minus 200.5. Yeah. So we saw again that we take the average of this. Yeah. And we can do the same with our second leaf. We just take the average. It's 804. So that means that y predict to 1 is going to be 402.